Hello everyone. I'd like to finish the discussion that we started on threads now. But real quick, I want to take a little segue for the Windows students. The Mac students can skip this section real quick. But Windows students, I want you to verify that if you go to Program Files, you have a folder called Java, and in that folder there's another folder called JDK 1.8.0_111. You should have that if you installed NetBeans, I believe. If you don't, let me know. We'll figure out another way. But assuming you have that, okay, so you should also, if you've installed Cygwin, have this folder Cygwin64 in your C drive. So if you go to Cygwin64 in Home, and then your username, this is where you start off when you launch Cygwin. That's the folder that the terminal starts in. So in particular, you can see when I say pwd, okay, I'm in /home/ctrailing, and so that's print working directory. If I type ls, it tells me, it lists all the files that are here. Okay. Now, I want you to do one more thing, which will make sure that you have Java set up. I want you to write this command, and I'll email it as well, but it's curl http://www.ctrailing.com/.bash_profile. Right angle bracket .bash_profile. What the heck did that just do? Okay, so I put up a file on my website that points to the Java that I just showed you. So if I look at what's in here, it has this little thing which just tells the terminal where to find Java. So once you've done that, you can relaunch Cygwin. So close it, open it up again. And now when you type Java C, it should come up with all this stuff. If that didn't work, it'll say not found. Let me know. We'll have to work that out so you can do the next lab. Okay. But so here I am, and let's get back to what we were talking about before. So I see in here there's a folder called Week 7 Threads. So let's go into it. And I will also open this up in my text editor, which is Visual Studio Code. So let me go ahead and open up that folder. Week 7 Threads. And so just to remember, we had left off doing this primes thing where we set up some command line arguments to set off some threads. So we said, how many primes do we want? That's the first command line argument. And then we also said, how many threads are we going to use to compute them? So if I say Java C primes.java to compile it, and now I say Java primes, let's get the first 10 million. And I'll use 6 threads. Okay, so 6 things running in parallel, and it counts them in different ranges. Okay, cool. So that's where we left off. Now, that worked great, but I want to show you some danger that you can run into with threads. And I can show it even on a very simple example. If you look at this class counter here, this is a very simple wrapper around an integer, essentially. So it's going to start at 0. It's going to store just one member variable, C, that starts at 0. I'm going to have a method called increment and a method called decrement. Increment adds 1, decrement subtracts 1, and I'll have a toString that returns a string representation of it. Okay, so nothing really amazing here. But if I say something like counter is equal to new counter, if I instantiate a counter object, and then I, in a loop, say go 10,000 times, and I say counter.increment, then at the end, if I print it out, it should say 10,000, right? So let me go ahead and compile that. So I'll say Java C counter.java, Java counter, and I see 10,000. Okay, whoop-de-doo. But yeah, so just, that's that class. Now, what we're going to do now is try to have a bunch of threads update the same counter at the same time. So, and we're going to do the following. So every time we add 1 in a thread, we're also going to take away 1. So we're going to undo the work that we just did. So here I'm just showing in the main again, but if I add 1 and take away 1, it doesn't matter how many times I do it, I should end up with 0, right? Good. Okay, so I ended up with 0 there. So let me start to make a thread class around this that will take a counter object as an argument. So I'll store the counter as a local variable of this thread class called myThread. And I'll pass that along to the constructor. And I'll also pass along the number of times that I want to do this increment decrement thing. Okay? I'll call that n. So counter is the counter object. N is the number of times I want to increment and decrement one right after the other. Okay. All right, so I've got all that. I can say this dot n is equal to n. And now what I'll do is I'll make a method. I'll call it void execute. And I'll say for int I equals 0, I is less than n, I plus plus. And I'll say counter.increment, counter.decrement. And when I'm done, I'll just print out the counter. I'll do it in the main instead. Okay, so what I can do here is in the main, I'll make a counter. And all this is doing, this is just wrapping around the counter. So far, I haven't done anything really different from what I already did in the main here in the counter class. But I'm making some stuff that will allow me to show you a bunch of threads doing this at the same time. So if I want to do something similar to what I did in the main of counter, I'll say, I'll send it the counter object, and I'll tell it that it has to go 10,000 times. So now if I say thread.execute, and I say system.out.println counter. So this is taken in the counter object. It's taken in a reference to the counter object into the constructor. It's stored away that reference in this variable here. And then when I call execute, it's used that reference to call increment and decrement a bunch of times over and over again. And then I print out the result. So this is like a really fancy way of adding one and subtracting one a bunch of times. Let's see, so if I say java c mythread.java, that's the one I want to write. That's the one I want to run. I say java mythread, then I get 0. Okay, same result so far. Now, let's say that I want to have a bunch of threads that are going to add and delete from this at the same time. Okay, so what I can do is I'm going to pass the same counter object on, but to different threads. So now I'm actually going to have this implement the runnable class. Or sorry, the runnable interface. And it's telling us there's a problem because it needs to implement the abstract method run. Okay, so actually when we're doing threads, the thing that executes when the thread runs is a method called run. So when I start a thread on this object, it will call the run method. So actually, I named it execute just to make sure you're paying attention. It's really called run when we go into do the thread. Okay. So, and we don't call it directly, it's actually the thread class that calls it. So we need to make an object of type thread and pass this along. So what I'll do is, okay, so I've made a counter. Let's say I want to have 4 threads that all do the same thing. They're all going to add 1 and subtract 1 10,000 times. So I'll start them off here, and I have to say new thread, pass along the thread, dot start. Okay, and when it does that, it will call the run method. They're in a queue, and then they start running, and it'll do this. Okay. So there are 4 threads that are going on the same counter object. They're each adding something and subtracting something. Let me wait till they're all done. So this just starts them. Now they're going in the background. The code's going to keep going. they haven't necessarily finished. So let me just wait a second. So I'll say this thing, thread.sleep. There's a static method in the thread class that allows us to pause execution. And there's technically an error that can be thrown here. So I have to do this thing, which I haven't talked about too much. Don't worry about it. But this is just so I can wait a second for the threads to finish. And then at that point, I'll print out what the counter is. Okay, so really, all right, so what this is going to do, there are 4 threads that are adding and deleting 1 10,000 times. So really, it's going to go 40,000 times plus and minus. But it should still be 0 at the end, right? You know, nothing has really changed other than I'm having 4 threads at plus and minus at the same time. Okay, so let's see what happens when I do this. So what does it actually print? So it's going to wait a second for the threads to finish. Huh. 213. Well, that's not 0. Well, that doesn't make sense because I ran 4 threads and they each added and subtracted. And every time they added, they subtracted. So what's the deal? Why did it get 213? Let me run it again. 13? Well, that's a different number. 20? 6? It's like random. So what the heck is going on? It should be 0, right? Every time I increment it, I also decrement it. All right, so here's the deal. These threads are working on the same object. They're actually calling increment and decrement on the same thing in memory. And something called a race condition happens. So even for increment, we're going to run into problems. So let me actually even just get rid of the decrement for a second. If I were just incrementing, I would expect the final result to be 40,000, right? Because each one of these threads is going to add 1,000. But even with the increment, we don't get there. We don't even get close, actually. You know, this is supposed to be 40,000. We don't even get halfway there most of the time. So even with just increment, we're going to run into a problem. And so here's what it is. So let's imagine the following. So in our way of thinking about it, we're really thinking that, so we have this statement and counter for increment. C is equal to C plus 1. So what'll happen is, let's say that at some point in time, counter that C is 1,000, right? So let's say at some point in time it's 1,000. And then we say thread 1 reads C and adds 1 to it, getting 1001. And then thread 1 writes 1001 to it, right? Okay, now thread 2, let's say once that's finished, thread 2 reads C, which is 1001 now, because thread 1 finished. Adds 1 to it, getting 1002, right? And then thread 2 writes 1002. So far, so good. But here's the problem. These operations are interleaved with the threads. We have something called a race condition. We don't really know what order these are going to run in exactly. It depends on which one gets lucky and gets to go first. So in this race condition, it's also possible that we start with thread 1 reading C and getting 1001, but before it writes 1001, thread 2 actually reads C. Thread 1 has not written back 1001 yet, so thread 2 is going to read 1,000 still, because thread 1 hasn't updated. So it's going to add 1, and it's going to get 1001. Okay, now thread 1's ready to write, so thread 1 writes 1001, and then thread 2 writes 1001. Okay, so see, the problem was that we read in thread 2 before we wrote in thread 1. And so actually at this point, thread 1 writes something, but thread 2 overwrites it, whatever it is. So this is the reason that we don't climb up high enough, because so many of them are competing with each other to read and write at the same time. They don't wait for each other to finish before they read and then compute their thing. Okay, so how do we fix this? Now this is really a topic for a much more advanced class in operating systems or computer architecture. But I want to give you a taste of it, and I'm going to show you just a simple way to address this. What we have to do is create something called a lock. So every time we want to do an operation where we know that the threads can end up in a race condition with each other, we have to lock out the object in memory that would cause this problem. So what I say is that there's a command called synchronized. So if I say synchronized counter, did I spell this right? Synchronized, I missed the end. Okay, there we go. Synchronized counter. So what this will do is it'll create a lock. It'll say, if this thread is about to do this, it is going to have exclusive access to counter. It's going to shut the door on that counter. No other thread can touch counter until this is done. Okay. So that's what synchronized does. So now if I run this, so I'm just doing the increments. So I have 4 threads going 10,000 times. I should get 40,000. Now I'm good. Okay, beautiful. So that fixed it. And just to show you that this also works if I have the decrement here. If before I do the decrement, I say synchronized decrement, I make sure that I can go through that entire read and write for the decrement as well. Whoops, so counter is the object that I need to lock here. And so just make sure that we get 0 now. Okay, we do. So this is now what's called a thread-safe implementation. Now this is not always the best way to do it. We end up in situations called live lock and deadlock. And just to give you an idea of what it is, it's like if two people are walking towards a door and one person wants to hold the door for the other one. But let's say that there are 2 doors and you want to hold this door and the other person wants to hold this door. So the other person holds this door and waits for you to walk through. You hold this door and wait for them to walk through. But if you both get there at the same time, who's going to go first? And this happens to me all the time at the supermarket. It's so annoying. I have my shopping cart. I'm trying to go somewhere, and this person's like, no, you go. And I'm like, no, you go. And so you can end up with this issue when threads are synchronized. It's like they both kind of got there at the same time. They were ready to do their increment. Which one locks first? So that is an issue. But that's an issue for another day. It's good enough for now. But what you want to be mindful of is try to minimize the amount of times that you have threads writing to the same location in memory. That will cause a lot of problems. You have to synchronize them or do something else fancy. So it's good if you could just minimize the amount that you do that. If you're just reading from something and computing things from it that are independent, like we were doing with the primes, these were all independent of each other, then you're okay. It's just when you're using the same objects between different threads and you're writing to them that you have to really worry. Okay. So I'm just going to ask you a couple of quick questions about this, just to check your comprehension. And then I'm going to talk about the lab that uses these ideas. Okay.